All right, let's do an example here. So the first thing, we're given this triangle. So we've got 3, 4, and we've got the hypotenuse. So the first thing we have to do is figure out what the hypotenuse is. Now, if you know the special triangle, then you already know what the hypotenuse has to be. But let's use the Pythagorean theorem and figure it out. So we know that these two angles, or these two legs squared, have to add up to the hypotenuse squared, right? So a squared plus b squared equals c squared, right? So we know that 3 squared plus 4 squared has to equal the hypotenuse squared, right? Okay, so that's going to be 9 plus 16 equals, I'm going to just use c here. Let's just use c just to make it easier. And so that equals c squared, right? So this is going to be 25 equals c squared. So that means if I take the square root of both sides, and it's only going to be the positive one that we want because we're talking about lengths. So we only want the positive square root. So it's going to be c is equal to 5, which is correct. Okay. So now, using this, let's evaluate all of the 6 trigonometric functions. So now we know that sine of theta has to equal what? Opposite over hypotenuse. So that's 4/5. You might remember seeing this before. Oops, not sine again. Cosine is adjacent over hypotenuse, so that's going to be 3/5. And then tangent theta is opposite over adjacent, so that's 4/3, right? So now to get the other ones, cosecant theta, secant theta, cotangent theta, so are just the reciprocals of these, right? So this would be 5/4, right? 5/3, 3/4, right? And that's it. Cool. Have a great day.